Hi everyone. Our next unit is going to be looking at exponential functions. So we're going to do a refresher of our exponent laws first of all, and as well we're going to take a look at a couple of new exponent laws next lesson. But just a review of the ones that we already know. So if we're taking a look at x to the power of 6 times x to the power of 4, we know that that means that we're going to have 6 x's all multiplied together here, and then we have another 4 x's all multiplied together here. Well, if we're multiplying 6 and we're multiplying 4, that means that we can rewrite this as x to the power of 10. And our law to show that is if we have, as long as we have the same base, we are simply going to add our exponents. In the next case, we're just going to fix that. That should be x squared for the second one. And again, x cubed divided by x squared can be rewritten as x times x times x over x times x. And we know that we can cancel one of the x's on top with one of the x's on bottom, which means that we're just left with x to the power of 1. And again, our exponent law that we show that with is that if we have the same base, again, this all requires the same base, that we can just subtract our exponents. In our third one here, our exponent of 4 on the outside means that we have 4 of those sets of brackets. And our first exponent law here told us that if we have the same base, we just add up all of our exponents. So adding up all of our 2's there, we get x to the power of 8. Well, we notice again, if we have double exponents on a single base, we can multiply our exponents. So we would have x to the power of m times n. And note that in these cases, our base does not change. It's just how many of them that we have that change. Next one, again, we would have 3 sets of brackets. We'll notice again, if we have the same base, we can add the exponents. Well, we're going to add those ones that are on all of these bases. When we do that, we get x to the power of 3, y to the power of 3. And again, that just shows that we're multiplying those exponents on our bases with the exponent on the outside of the brackets. So if we have xy to the power of m, we would have x to the power of m, y to the power of m. Next one, we have a fraction inside the brackets. We have exponents on the inside of the brackets, but we also have an exponent on the outside. Looking at this question, we would have, and let's just fix the variable on the bottom, that should be a y. So if we had those brackets twice, again, we would just add the exponents on the same variable. So we would have x to the 18 over y to the 4. Well, as in our previous rule, we noticed that that exponent on the outside simply gets multiplied by each exponent inside. And remember, that also applies if it is a number as well. So if we have a base, but we also have a coefficient out front, that exponent has to apply to all the pieces inside the brackets. So we would have x to the m, y to the m as well. Now, if we have x to the power of 0, this would mean, if we think about x to the power of 3 over x to the power of 3, and we think about our subtraction of exponents. Well, we know that 3 minus 3 gives us 0. If we look at it this way, x to the 3 over x to the 3, anything divided by itself has to equal 1. So therefore, we know that anything to the power of 0 is just 1. Now, our next one, we have x to the power of 4 over x to the power of 6. if we think about it in terms of subtracting our exponents, so our law number 2 above gave us x to the power of negative 2 once we subtract these exponents. So if we look at it another way, we know that we're going to have 4x's on the top and 6x's all multiplied together on the bottom. If we think about canceling, one with the top, one with the bottom, all we have left on the top now is 1. So that's going to be 1 over x squared. Well, then we know that x to the power of negative 2 has to be equal to 1 over x squared. So that tells us that our power law, if we have a negative exponent, because we don't know how to do negative exponents, we are going to flip it and change the exponent to a positive on the bottom. So if it was a negative exponent on top, flips to the bottom. If it was a negative exponent on the bottom, it flips to the top. And that also applies if we have a fraction. The x to the power of negative m, y to the power of negative m, well, the x to the power of negative m flips to the bottom and becomes a positive exponent, and our y to the power of negative m flips to the top and becomes positive as well. So we know that if we have a fraction, we can simply flip that fraction and make our exponent positive. Okay, so let's take a look at some examples using these laws. Our first one, we know multiplying we're going to add, dividing we're going to subtract our exponents. So we're going to have 4 to the 3 plus 4 minus 2. So we're going to get 4 to the power of 5. In our next question, we need to get rid of our double exponents first. So we're going to have 5 to the power of 8 over 5. And now we're going to subtract those exponents. And remember, if it doesn't have a number on it, it's to the power of 1. So we get 5 to the 8 minus 1, which is 5 to the 7. For part C, we still have the same base. So we are still going to keep our base and subtract our exponents. 3 minus 2 leaves us with 1, which means that we just have 1/2 to the power of 1, which is just 1/2. Part D, remember that we have to apply that exponent to all the pieces inside the bracket, including the number. So we're going to have 32x to the 5, y to the 5, and that's as far as we can simplify. Part E, again, we do our multiplication first, which includes multiplying exponents. So we're going to have x times x to the 21. Now we can add our exponents and get an answer of x to the power of 22. For part F, we have a triple exponent. So we're just going to multiply all those exponents together. 3 times 3 times 3 gives us y to the power of 27. Part F, we want to simplify inside our brackets first. So getting rid of our brackets on top, we get x to the power of 4, y to the power of 4 over x. We still have to the negative 2. Notice that we can also take away the 1 on the x's, so x to the power of 3, y to the power of 4 to the negative 2. And now that whole thing is going to, actually we're going to apply our number, our exponent, outside the brackets first of all. So we get x to the negative 6, y to the negative 8, which both of those are negative. Both parts are going to flip to the bottom, and we get 1 over x to the power of 6, y to the power of 8, and it stays our fraction. Part G, we're going to multiply each piece together, piece by piece. So our numbers, first of all, we get negative 6. Then we take a look at x to the 2 plus negative 2 means x to the 0, so they cancel out or become 1. And then we add our exponents on our y, so we get negative 6y to the power of 7. For part h, we're going to divide. So first of all, our numbers, m to the 3 minus 1 gives us m to the 2. N to the 1 minus 3 means we get n to the negative 2. Remember, only the parts that have a negative exponent flip to the bottom. So we get 6m squared over n squared. Next one we have simplify, then evaluate. So our first one, we cannot evaluate a negative exponent, so we're going to flip that to the bottom first. Then we can apply our 3 squared, so our answer is 1 over 9. Anything to the power of 0 is 1. For part C, we're going to flip our fraction inside first of all and make that a positive exponent. And then 3 halves times 3 halves gives us 9 quarters. Now part D, a couple of things tell us that we're going to have to approach this one differently. We have 2 different bases. We also have a plus. Remember, we can't combine things with different bases, and we also don't have any power laws for adding or subtracting of terms. So we have to calculate these separately. So 2 to the power of 0 is 1, and then 4 to the negative 1 becomes 1 quarter, and getting a common denominator, 4 quarters plus 1 quarter is a total of 5 quarters. For part E, we're going to be adding our exponents in the first part, and then we're going to be subtracting our exponents. This is where it becomes important to pay attention to the signs. So if we're subtracting a negative, that means we're going to have 6 minus negative 6, meaning we're going to add 6. So 2 to the power of 12. So we're going to have, and we can start counting by 2s, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096 for 4 to the power of 12. For part F, we're going to have, note we do have the same base of negative 12, and we're going to subtract our exponents. Well, the other way we can look at this is that 5 of our negative 12s on the top cancel, and 5 of our negative 12s on the bottom cancel, so that we're left with 1 over negative 12 squared. And if we square negative 12, we get 144, so we get 1 over 44. We could also have figured out that we had negative 12 by subtracting our exponents, negative 12 to the power of negative 2, then we flip it to become 1 over negative 12 squared, which is still equal to 1 over 144. Now notice that when we flip things, the signs of our numbers themselves do not change. It is only the exponent that changes from a positive to a negative. For part G, we're going to simplify inside our brackets first of all. So we're going to have 5 to the power of 6 over 5 to the power of 7. And that's all going to be to the power of negative 1. And inside our brackets, we're going to simplify. We're going to subtract our exponents. And now we're going to apply the double exponent. So 5 to the negative 1 times negative 1 gives us 5 to the positive 1, which is just 5. So this is a good example where you want to simplify all of those exponents first, because we didn't actually have to turn around and flip anything. They all became positive exponents once we got rid of all the double exponents. Okay, so that's some review. You've got some questions to practice and go through to make sure